Yep. So what we're going to do now is we're going to export just these features so we can just work with them for analysis. So we're going to export them into a separate file. So you can right click on the points file and then do save as. Okay, you get the save as window. Give it a file name. I'm gonna browse and I'm gonna go to my data folder and I'm gonna call it Canterbury Places. Yep. And then make sure to click Save Only Selected Features. Because we don't want to again make a copy of the entire data set. We only want Canterbury cities. So make sure, because we already selected them, make sure to click that. Yep. And then hit OK. Oh, also, sorry, make sure that this is NZTM. That's, New Zealand class was Mercator 2000. And then hit OK. Right. So now that should give you only the points within Canterbury. Yep, yep. So just clear your selection there. Yep. And then now do your selection again. So select on Canterbury. So use, let's say you're in the selection tab. Click. Okay. Something is selected. So clear your selection again. Okay. Let me just click out symbology. For some reason it's probably a bug. Now select. Okay, now Canterbury is selected. So now you can just do the same thing. You go research tools, select allocation. I want to select places within districts and within. Run. And then we select them. Same problem?
I keep on saying there's a vector layer. Is not to this.
Oh, okay. Let's turn on your land districts here. I think what's happening is, for some reason in this version, symbology and now Canterbury is selected. Now we can do it's going to be places, the districts, Yep, so you get them all selected, right? Now to export it, right click on your points. For those of you who thought I'm just going through again just to make sure you export it. So right click on your points, click on Save As after the selection, and then make sure you click that Save Only Selected Features, and then give it a file name. Yep. So everybody should have that on the screen right now. Just the cities for Canterbury. Yep. It's a bit fade. What's going on? Creation of real field. Permission denied. Should I put it in a folder? Let's see. Just give it a name. Canterbury cities. So, all no spaces. So, 467 should be 2193. I think when you downloaded the data, you got it in the wrong coordinate system. Yeah, that's okay. You can always just do the save as, you can change it here. Search for 2193. So this one is, like I said, it's a separate coordinate system. Because maybe the shape, the polygons are on a different one, so it's not able to do the intersect. That's why all your data has to be in the same coordinate system. Just do okay. Yeah, are you good?
Yes, I see the ticket and it's Chihuahua.
Yep, and then give it a file name. You got it?
Oh, I already
Oh,
saved it.
sweet. Are you still downloading?
Yeah, I cannot even uninstall the old one.
You cannot?
Yeah. Because I don't know why it's not showing in my.
Huh. I wonder if you can just download the older one.
Yeah, it's I'm downloading that. I was thinking of installing that first one.
Yeah.
First and then installing this one.
You can just try installing it, it might just work. Okay, so everybody should have, now we're going to do the same for the rivers. So let's go ahead and do a selection. Let's do a select by location again. And the vector research tools, select by location. I'm going to pick my rivers. And my intersection layer is the same. It's the regions. And within, and run. This might take a bit while because the reverse data is much bigger, it's much more complicated, so it might take a little longer. Make sure that Canterbury region is still selected. Because I don't think mine is, so it's going to select the entire river database. Are you good?
Yeah.
Yeah. Oh, just make sure that you select Canterbury. So yeah, click on that. Select feature, click on Canterbury, just the region. For the certain points, you want just the region. color works. Just change that. Okay. Whoops. That's bizarre. Okay, so you've got Canterbury selected. Let me do it again. So I've got okay, I've got Canterbury selected. I'm going to do vectors, research, select the location, my rivers that are within the regions, and go. And then make sure to export that to its own shapefile as well. Okay, my rivers on. Now I'm going to do save as my rivers, only the selected features. I'm going to browse and I'm going to call it Canterbury Rivers. Save, 2193. Okay, so now if I turn other rivers off, okay, so now all I have is I'm just looking at Canterbury points and Canterbury rivers. Right? Everybody on here? Okay, so now we are back to our problem. Within Canterbury, where are all of the cities that are within 5 kilometers of a river? So to do that, we do something called a buffer analysis. So buffer, what it is whenever you have a point or a line, what you can do is you can put a buffer around it. So a distance of 5 kilometers around a point is pretty much a circle with a radius of 5k. Yep, that's the buffer around, and that's as the crow flies. It's not how you would navigate, it's not how you would traverse, it's just how a crow flies. Straight line distance from the point is pretty much a circle with a radius of 5 kilometers. In a line, if you do a buffer, it's pretty much a 5 kilometer oval, or whatever shape of the line is, from the line out to the edge of the buffer. Right? That's 5k, that's 5k, and that's 5k. Yep, does that make sense? And the same thing goes with the polygon. So if you have a polygon, then it's going to be a weird shaped buffer based on the shape of your polygon. Something like that. So it's going to be this is going to be 5k from here, that's going to be 5k from there, so on and so forth. Right? So it's a buffer around your particular point. Now these are just what we're going to create are simple buffers, just as the crow flies. But what you can do, there are some other algorithms that you can download available for free in plugging, in the plugins. For example, routing. Right? If you want to route, when you go from, let's say, here is CBD, and let's say here is the airport for Christchurch. Okay? Now as the crow flies, this might be only 5Ks. Okay? But if you drive it, you might have to go 10Ks to get there. Right? That's a different kind of buffer. Those are called routing and service areas. Right? And so there are plugins available within, but that requires a little bit more data. You have to know all the roads to get from here to here. What are my different routes that I can take? So you have to have the roads layer, and then on those roads layer you can do buffers, and based on those you can generate the closest distance from you to the air. Okay? But for now we're just going to do as the crow flies. So let's go ahead and do that. So let's go to vector, click on the vector tool. Under geoprocessing tools, there's something called a fixed distance buffer. Yep. Now there are two things. There's something called a variable distance buffer and a fixed distance buffer. The difference between the two is, let's say you have, what's an example of a variable distance buffer? Okay, so let's say you have a point of all your weather stations. Okay, and you have the distances that it is close to its base station. So you have a weather station and you have, let's say a calibration station somewhere nearby to it. And each weather station has got a distance to its calibration station. If you have that information available as an attribute and you want to create a buffer around your weather stations for that, you can use that field and it will say, okay, this point needs a buffer of 5K. This point may only need a buffer for 2K. So it's variable distances for each point based upon an attribute. But what we are going to do is we're going to just do a fixed distance buffer, just to kind of understand what the concept is, and we can go around and play with it. And this, so we want Canterbury places as our input layer. So we want to look at all the we need our rivers as our input layer, because we are looking at cities that are within 5 kilometers of a river. We are not looking at rivers that are within 5 kilometers of a city. Right? They're two different problems. So we are looking at cities that are within 5 kilometers. So let's go ahead and do a distance of, this is where again coordinates and projection systems come in. Because we are using NCTM and all of our units are in meters, these need to be in the same units as your data. Okay? So here all of our data are in meters, so we need to provide our distance in meters. So 5 kilometers is 5,000 meters. So I'm going to go ahead and put 5,000 there. Yeah? And then I'm going to hit run. Okay? So it's going to create buffers around our rivers. There you go. If I zoom in now, I can immediately visually start looking at which cities are within 5. Okay, let me bring in my rivers on top. And let me change the color. Right. So here are my rivers, and here are my 5K buffers around my rivers. Right? Immediately, visually, I can start telling, oh, these cities are not in it, these are within. So these are my cities that need to be addressed. Right? But now, again, we are looking at a small region, so maybe if it was just here, I can start looking at them and click my cities and select them. But what we want is we want to be able to go to our emergency management and give them a list of cities. Here are all the cities that are under threat, right? So what we're going to do is we're going to select all of the cities that are within that buffer. So it's the same process as before. We're going to go to vector, we're going to go to research tools, select by location. Yeah, this time the layer to select from is Canterbury places, and your intersection layer is your buffer, right? And we want within, or maybe we can even do intersects. Even if it's on the border of the buffer, I want to pick the city. Yeah? So I'm going to do that, and then I'm going to run. Boom. So here are all my cities that are within 5Ks of my river that are under threat, and now I can export them. I can go to my Canterbury places, and I can say save as. I can call it under threat cities, also places, cities, places, save only selected features. Okay, turn it off, and there. Now I have all my cities that are within my, I can send that shapefile off to the emergency management, and now they can immediately start addressing these places and what they need to do for emergency response. Okay, so this is in the case of a flooding happens of a river or any of that nature. Right, that was a simple buffer analysis that we can do. Does that make sense? Is that kind of clear how that works, how kind of spatial relationships work between features? So this is why it's very important. You cannot do this if you just have an Excel spreadsheet, or if you just had a SQL table. It's just not possible because you don't have the geometries and the spatial component that goes with the GIS. Right? Okay. So the next step, go back to my PowerPoint here. Sorry. Okay, yeah. Then we can do something called influence diagrams. So let's say we have, let's assume that these are not cities, these are some weather stations points that we have. Okay, so we have weather stations that are scattered around, and what we want to know is what is the influence of each of these weather stations to our land. Okay, in the sense that if we have these weather stations spread around, and I want to get my temperature here between the two weather stations, which weather station should I go with? Right, so you have, let's assume that these are not places, these are some weather station points, and I want to say, okay, here are my weather stations, but I want to get the weather here. Okay, now which weather station do I choose to get that weather? Right, so for that we use something called Voronoi diagrams or Peasant polygons. Okay, this is a very simplistic way of looking at it. There are a lot more complicated algorithms that you can use to choose which station to use. But the first exploratory analysis is something called a Voronoi diagram. And what that does is it takes all the points that you have, measures the distance between them, cuts them in half, and then says all of that is that station. And then from here to here is also a distance. And let's say that's halfway. So it cuts that out and says, no, now this station's influence is only this much. And then it looks at these 2 points, and let's say halfway is there. That's my influence, right? So it's the influence that each point has relative to all the other points in space. Okay, so let's do a quick example here. Just on the same Canterbury places, let me turn off my buffer. I don't need it right now. I don't need my rivers right now. I'm just interested in my points in my Canterbury places. Zoom out. Okay, so for this exercise, we're assuming these are weather stations. I'm going to go to vector, and it's under, keep changing this, under geometry tools, called Voronoi polygons. You see that? Yeah? So you click on the Voronoi polygons, and I'm going to pick Canterbury places. So the buffer region is, you have to have some kind of an idea of what your weather stations are able to capture, right? Some are very powerful, they can capture long distances, some are not. Some only capture at the point, they don't go out and capture. So for this example, let's just go with 500 meters. Okay, I'm just putting that number out of thin air, it's just completely random. Yep, so put 500, and then we'll hit run. There. So these are my influence polygons. So what that tells me, and then when I identify a polygon, so if I click on a particular polygon, identify it, it tells me the station that it came out of. So that the Waimakariri district and White Rock, that's the name of the point, right? So what this is telling me is that point influence is that much. So if I zoom, I have got 2 features here. Let me just clear my identifier here. We zoom in, sorry, and let me go further into Central City. Let me pick that, right? That's St. Martin's. So that point, St. Martin's, influence is that region there. Okay? I can quickly turn on. So yeah, is everybody at that point? No.
Can you just go back to when you chose Voronoi polygons?
Oh yes.
Yeah.
Yeah, let me do that again. Let me remove this. Okay, so here are our points. Let's go to vector, geometry tools for my polygons. And the buffer region, this is the buffer that I'm putting in as 500 meters. And I'm just hitting run for my Canterbury places. Yeah.
Thank you.
So now what I can do is, for those of you who have the Google satellite imagery, you can turn that imagery on now. And then you can double click or go to the properties of the my polygons, go to properties. Yeah. And then you will see a transparency slider. Okay, move that to like 50%. And change your color to like yellow or something like that, something that you can see over the imagery. I'm just going to change it to yellow. It's easier. Okay, now suddenly, right, you have your polygons, you have your weather stations, and you can see the imagery underneath it. Yep, with transparency. So now if I zoom in, I can see the influence each of my points have with respect to each other. Yeah? Can you see that? So immediately now that's very helpful. But visually you can start looking at, let's go out of the boonies a little. Let's go out in the, as you get further apart and as cities get further apart, as you go to more rural areas, your polygons get a lot bigger because the distance between the cities are a lot bigger, right? So suddenly you can start saying, oh, that weather station is covering a massive area, I may need to put one more there, right? Immediately, by just looking at visually, you can start looking at these things.
And you get a really strange effect from when you reach the boundaries.
Yes.
Yeah.
Oh yeah, out here, these ones.
Yeah.
That's because, yeah, it's saying that now this point is for this whole region because there are no other cities around here. Yeah? So immediately, visually, you can start getting an idea of what you need to do next. In this case, so if this was a weather station, it is not, but if it was, that station is measuring weather there, which might be really good, but you have a big mountain here. Obviously, the weather on top of the ridge is not the same as the bottom of the mountain, right? So you might want to see, maybe on top of the hill I need a weather station, because now this is the only station I have that's capturing all this information, right? So these kind of insights are not available by just looking at tabular data. This is why you need geospatial technologies. This is why you need GIS. And as you can see, just within 5 minutes, you can get this information. Once you know how to do this, and you do it pretty regularly, it just becomes second nature, right? And the hard part here is thinking about these things spatially, right? You need to think about what can I conceptually do, and if you can conceptually do it, I'm sure somebody in the world has written a code for you to do that. And it's available in the plugins, it's available in different libraries, Google's your best friend. You can pretty much find anything you want. Somebody has always thought about it before. It's only the idea of how can you apply that particular concept to your problem. That's where the innovativeness comes in. There's no point reinventing the wheel because there's no point writing the whole code to create these polygons. That code is already written, you already have that function. How can you use that to solve a problem? Right? That's where the innovation comes in. Yeah, does that make sense? Clear? Right. Now what we're going to look at is we're going to look at some raster analytics. So like I said, data comes in various formats. Vector data is definitely a lot more precise. It's a lot easier to deal with. It's a lot smaller data sets. Raster data